All right. Hi, everyone. It was great to hear the other talks so far. And my name is Helena McMonigal. I'm a third-year graduate student in the School of Aquatic and Fishery Sciences. And I'd like to address this question today: what could deep sea fish and their poop do to absorb our greenhouse gas emissions? I'd like to thank my department and the National Science Foundation and the Ocean Twilight Zone project at Woods Hole Oceanographic Institution for support for my research. So where do these fish live? They live in the ocean twilight zone, which is the layer of the ocean beneath the sunlit zone and above the midnight zone, which is completely dark. So some, but not much light reaches this twilight zone layer. For scale, the bottom of the twilight zone is about as deep as 5 Seattle Space Needles stacked on top of each other. So this is the layer from 200 to 1,000 meters deep. And why should we care about this deep offshore part of the world and the fish that live there? One reason is that they are extremely abundant. So their abundance has been estimated roughly at 10 billion tons. And if that number doesn't mean much to you, it didn't to me either when I first heard it, so here's some context. Other fish in the ocean are estimated at roughly 1 billion tons, and the amount of seafood or fish that we catch every year globally is about something less than 1/10 of a billion ton. So other reasons these fish could be used for fish meal and other seafood products, which are used to feed our livestock, our aquacultured fish, and maybe even your pets if they eat a fish-based meal. These Twilight Zone fish also provide food for other important species like the salmon shown here, tunas, swordfish, and marine mammals. And finally, the topic of my research is that these fish play a role in carbon cycling in the ocean. So this is in the ocean's role in absorbing carbon dioxide from the atmosphere and transporting some of that down into the deep ocean where it can be stored for long periods of time. So one important process to understand in learning how this works is diel-vertical migration. This is a process in which every night trillions of organisms across the globe swim up to the sea surface where there's abundance of food. They fill their bellies and then they swim down into the twilight zone as the sun rises. And in the twilight zone, they can hide from visual predators. So we'll come back to that thought. But another thing to know is that the oceans absorb about 1/4 of our carbon dioxide emissions. So carbon dioxide is emitted into the atmosphere, it equilibrates with the sea surface, and then much of that is absorbed through these microscopic plants called phytoplankton that undergo photosynthesis and absorb carbon dioxide just like how our forests do. So these microscopic plants are eaten by small animals, represented here in orange, called zooplankton. And these small creatures called zooplankton are eaten by fish and other animals that undergo this process of diel-vertical migration. So these animals fill their stomachs with carbon-rich food, they dive down into the twilight zone, and here they release much of that carbon. One way that they do this is through their fecal pellets, as we call them, or their poop. And this is an especially important process because that carbon in their fecal pellets can sink very deep and be stored for very long periods of time in the ocean. These fish also release carbon dioxide through their respiration, through breathing out carbon dioxide just like we do, and by being eaten by other predators that live in the twilight zone or even deeper. So there are these various different mechanisms that these fish transport carbon into the deep sea, and the topic of my research is on narrowing down the uncertainty in these estimates of how much carbon these fish are transporting down into the twilight zone. Where is that carbon being dropped off and how deep does some of it sink, such as through their fecal pellets? And basically the deeper carbon sinks, the longer it's stored. So in some cases it can be stored as long as hundreds or thousands of years. So my work involves field work to measure rates like these respiration rates, as well as using computer models to calculate how much and where and how long is carbon being stored. So I hope I've convinced you that twilight zone fish and their poop are involved in how the ocean absorbs carbon dioxide. And I think this research is important because at some stage, as this developing fishery expands, we'll need to make informed decisions about the extent to which we want to harvest these fish for providing fish meal versus leaving them in the ocean to support these other services. So thank you so much for listening, and I look forward to your questions.